Welcome back, guys. This is chapter 54, and we are on to part 4. And this section is really going to focus in on disturbances. So, what happens to our community structure when some sort of event comes in and changes the structure, particularly from an abiotic standpoint? And historically, ecologists really sort of favored this idea that communities were most stable when they were in sort of a state of equilibrium. All right. So we got to a certain point, and in that succession of development of a community, and once it reached that equilibrium point, everything was happy and copacetic, and it was the most stable it could be. But more recent research is kind of saying that may not necessarily be true. All right, and so there's been more emphasis recently looking at sort of this non-equilibrium model, so really taking it from one extreme to the next, and saying that communities are constantly changing and that there's actually some benefits to some disturbance rather than sort of not touching anything at all. All right, and so when we talk about disturbances, we're talking about a couple of things. We're talking about either events that change a community as a whole, all right, or some sort of removal of organisms from a community, or altering the resources that are available to that community structure. So we're really sort of favoring more of this intermediate disturbance hypothesis, where you've got moderate levels of disturbance that actually foster a higher species diversity than having too much disturbance or not enough. So when you've got too high levels, you're really excluding these sort of slower growing species, and so they're never really capable of fully reaching their maturity and getting to their stable point. And so too much disturbance is a problem. But not having enough disturbance allows sort of those dominant species to take over and exclude some of those less competitive species. And so what we end up seeing here is that a lot of your park rangers and people who are sort of taking care of large, vast places of land are finding that that intermediate disturbance is actually necessary. All right. So one of the biggest things I've heard park rangers say is Smokey the Bear is kind of a problem for them. And that's because as we're better understanding this intermediate disturbance hypothesis, a lot of places are doing controlled burns. So they're forest fires, but they're being done in a managed, controlled way. And people get upset because Smokey the Bear says you shouldn't have forest fires, it's bad. And yes, in sort of that all-out, uncontrollable burn, it's a problem. All right? But if it's done in the proper, managed way, it's actually better for the health of that ecosystem than nothing at all. All right, and so they'll go out, they'll do controlled burns. In fact, redwood species, big, tall redwood trees out on the west coast, their cones won't seed without fire. They need that heat. So there are helpful benefits to some of these, assuming they're done in a proper managed way. So a lot of this really came about after a huge wildfire in Yellowstone back in 1988. And what we really ended up seeing as kind of an accident was that the communities that responded after the fire, after this massive disturbance, really were actually more diverse and more healthy than before the fire, all right, which is sort of what they're showing you here. Okay, we saw it, same thing in Mount St. Helens, all right, and the diversity that we see coming back is actually better than before. Now, keep in mind that the recovery of these huge scale events takes time. All right, it's not an immediate comeback, and so that's why we want to do it more managed if we can. Obviously, the wildfire in Yellowstone, the explosion in Mount St. Helens, these are things we can't control. We can't stop them from happening. But the more we can control what we can, all right, the more beneficial these sort of disturbances can be for the ecosystems, for the environments we're doing it to, rather than letting them get out of control if we can help it. Humans, of course, are the sort of most widespread agents of disturbance. All right, what we do to our environments tends to be more on the high disturbance end of things, where we're causing more problems than help. All right, but if we can be more aware of what we're doing and more aware of the disturbances we're causing, we can potentially continue to do disturbances in a way that actually benefits the community structure rather than what we're doing now, which is mostly just reducing species diversity. All right, so human disturbance in and of itself doesn't necessarily need to be a bad thing if it's done properly. Fortunately, most of the disturbance we're doing right now isn't necessarily being managed in the most efficient way. So any disturbance is ultimately going to lead us to some sort of succession. And when we talk about ecological succession, we're talking about disturbed areas that, once they're disturbed, what's sort of that stepwise progression in the replacement or the creation of communities. All right, so when you've got that sort of pioneer species that comes in first, that's typically when we're talking about creating new ecosystems, new communities. All right, sort of your primary succession versus secondary, where we've got the replacement of some of those more dominant, larger organisms, and then how did those get replaced over time. And so remember that your primary succession is new growth, completely new. All right, we're taking place where there isn't even soil to start with. We're starting on bare rock. All right, so we're starting with those pioneer species, those lichens, those mosses that are going to break down that rock to ultimately get us soil that then we can have grasses and small ferns and ultimately get to those larger dominant trees. And this type of succession typically happens after your melting of glaciers. All right, landslides, strip mining, volcanic eruptions, anything that's going to either lay down or expose bare rock. As opposed to your secondary succession, which typically happens after things like earthquakes, fires, floods, that kind of stuff that wipes out the community that's currently there, but it leaves the soil intact. All right, so it's going to get restarted by any sort of remaining species that manage to survive that disturbance and then grow ultimately to that climax community at the other end as well. Those early arriving species are particularly important for succession to happen and for it to be successful. All right, their purpose is kind of multi-step here. One, they're typically there to help facilitate the appearance of later species by ensuring that that environment becomes favorable for those later species. Breaking down the rocks to create soil in the first place, if we're talking something like primary succession. But also potentially returning nutrients to the soils and all of that. However, in some cases, they also tend to inhibit the establishment of later species. If they're capable of taking over, utilizing whatever nutrients is available, space that is available, it may become more difficult for later species to come in. In other cases, they may sort of tolerate later species but really have no impact on their establishment. So it all sort of depends on what that early arriving species is, what the circumstances in that particular successive community are.